Here we have a SAT math problem. Okay, let's go to the question. In rectangle ABCD above, AD equals to 12, AB equals to 6, and EG equals to 4. What is the area of triangle EFG? Okay, here in the given figure, we have to find the area of the triangle EFG over here. Okay, we have the length for the AD over here, that is 12, and also we have the length for this line segment AB, that is 6, and also we have the length of this line segment EG, that is 4. Okay, here our aim is to get the area of this triangle EFG. For this triangle, we can consider this side EG as the base. Then we have to get the height of the triangle EFG. So once we get the height of this triangle EFG, we can use a formula base times height divided by 2 to get the area of this triangle. Okay, how do you have to get the height of this triangle EFG? Okay, for that, what we can do is we can draw a vertical line from the vertex of the triangle F to the side AD of the rectangle over here. Since it's a vertical line, it will intersect the sides BC and AD of the rectangle at right angle over here and here. Now let me consider the two sides of the rectangle AD and BC. We know that in a rectangle, opposite sides are parallel. So the two line segments AD and BC are parallel. Now we can consider this AF as transversal because it intersects the two parallel line segments AD and BC. Okay, since the two parallel line segments AD and BC is intersected by the transversal AF, we can consider the angle measure over here and angle measure over here. These two angles are corresponding angles and they must be equal in measure. Okay, now we can consider two triangles. One is a smaller triangle EFG over here and the bigger triangle AFD over here. And this F is the common vertex for both the triangles, the smaller triangle EFG and the bigger triangle AFD. Okay, now let's consider the two angles, interior angles of the smaller triangle E and F, and let's consider the two interior angles of the bigger triangle, that is A and F. So the two interior angles of the smaller triangle EFG are equal to the two interior angles of the bigger triangle AFD. So the two triangles are similar by angle similarity postulate. Okay, now let me write the vertices of these two triangles in order. Let me take the vertex of the smaller triangle first. Let me take the vertex E in the smaller triangle. So the corresponding vertex in the bigger triangle is A because the interior angle at the vertex E and at the vertex A are equal. Okay, let me write it over here. And now let me consider the common vertex here for both the triangles. Let me write it over here and also here. And the third vertex for the smaller triangle is G and the third vertex for the bigger triangle is D. Okay, let me write it over here. Okay, here in the smaller triangle, we have the length for this EG, that is 4. So we can consider the side EG in the smaller triangle. Okay, now let's get the corresponding side in the bigger triangle. For that, we have to consider the letters at the same position. So that is AD is a side which is corresponding to this EG. Okay, now let me write it over here, AD. Okay, we know that the length of EG is 4. It is given over here. And the length of AD is 12. Okay, here 4 goes into 4 one times, 4 goes into 12 3 times. I am getting 1 over 3. Okay, here in these two similar triangles, EFG and AFD, so the sides EG and AD are corresponding sides, and here I got the ratio of the corresponding sides, that is 1 over 3. Okay, since these two triangles are similar and the ratio of the corresponding sides is 1 over 3 and their heights also will be in the same ratio 1 over 3. Okay, then let me consider the height of the smaller triangle. So this is height of the smaller triangle. Let me assume x as height of the smaller triangle, and here we know the length of this part, that is 6. Then what is the height of the bigger triangle AFD? That is x positive 6. Let me write over here. Okay, here let me take the ratio of the heights of the two similar triangles. First, let me take the height of the smaller triangle, that is x. Then the height of the bigger triangle is x positive 6. As I said earlier, in whatever ratio we have the corresponding sides of the two similar triangles, in the same ratio we'll have their heights, that is x over x positive 6 equals to 1/3. Okay, now we have to solve for x in this equation. Actually, x gives the height of the smaller triangle EFG. Okay, for that we can do cross multiplication. Then we get 3x equals to 1 times x positive 6. Okay, 3x equals to 1 times x positive 6 is x positive 6. Now let me subtract x from both sides of this equation. This x, negative x will cancel out. I am getting 2x equals to 6. Let me divide both sides of this equation by 2. Then this 2 will cancel out. I am getting x equals to 3. Okay, here I got the height of the smaller triangle 3. Okay, our aim is to find the area of the smaller triangle EFG. Already we have the base of the triangle EG, that is 4. Now we got the height 3. Okay, now we can get the area of this smaller triangle. Okay, let me write the stuff over here. That is the area of triangle EFG equals to the formula to get area of a triangle is base times height divided by 2. Okay, here the base is 4 and the height is 3 divided by 2. 2 goes into 2 1 times, 2 goes into 4 2 times. Here 2 times is 6. Okay, here I got the area of the triangle EFG, that is 6 square units.